So guys, for Unit 5, we started with interest, and we did compound interest and simple interest. So here are your formulas. Simple interest, your formula is P sub t equals P0 plus P0 times R times T. And your compound interest formula was P sub t equals P sub 0 times 1 plus R to the power of T. And then I want you to write down what each of the variables stand for. So in either formula, P sub t is the balance after t years, so it's what you end up with at any given time. 0 is the initial deposit, R is the interest rate, and then T is obviously time. I don't know why I didn't type that in there. So T equals time. Okay. So the example you guys are going to do with this has an initial deposit of $20,000, and the interest rate is 2.5%. So we're going to do calculate the simple interest after 1 year and after 5 years, and then for those same amounts, we're going to calculate the compound interest after 1 year and after 5 years. Okay, so before we get started, guys, remember that for interest, when we stick it into a formula, we can't write it as 2.5 because that's not what percent is. How would we write 2.5% as a decimal? 0. How many spaces do you move the decimal over? Twice. So that's going to be 0.025. When we did the test on this, I think that was the biggest mistake on these problems, is that you plugged in everything correctly except for the percentage. So just make sure that you're paying attention to what you're doing. So let's do simple interest first. So that's going to be our first formula. Round to the nearest dollar. So this is going to be, so simple interest, P sub t equals, what's P0? 20,000 plus, see, mine's going to be really squished, 20,000 times R. What's R? P, it says plus, 20,000 plus. I'm just plugging it into this formula, but mine is really squished. 0.025 times T. What is T in this case?
1 year.
1 year. So times 1. Yeah, my chart's really tiny. Okay. Let me zoom in for you all. So try and fit it all in the box if you can. And then we're just going to plug everything into the calculator. Make sure that you are using order of operations here, guys. So we have 20,000, 1, 2, 3, times 0.025 times 1, right? Which gives us the same thing. And then I'm adding 20,000. So what do we end up with? $20,500. So that's your answer. Okay. So let's do compound interest for that same amount of time. So it's P sub t equals P0, so 20,000 times 1 plus the rate, which is 0.025, to the power of 1 in this case. And then same thing, we have to do order of operations. So we have to do the parentheses first. So this is 1 plus 0, or 1 plus 0.025, which gives me that, to the power of 1. So I'm taking this number and raising it to the power of 1. So remember, to raise to a power, we have our exponent button right here. So you have your base, you press that button, and then you press the power, which in this case is 1, so it doesn't change anything. And then we multiply that by 20,000. And in this case, we end up with how much? 20,500. So actually the same amount, right? Do you think that will always be the case?
No.
Well, they're two different types of interest, so my guess is that that won't always be the case, but this was just after 1 year for each one. So what I want you guys to do now, I'll give you like 3 minutes, maybe 5. Do the same thing for 5 years for each type of interest. Okay, so for 5 years, simple interest, you should have got $22,500. Basically, you do the exact same thing, except you replace times 1 at the end with times 5. And then for compound interest, you should have got $22,628. So if you got a decimal, that's okay. Keep the decimal on the answer key that I have. It looks like they rounded up. But as long as you got that amount. You do the same thing, but your exponent is 5. So it's just plugging the numbers in. Okay? So let's look at, we also in this section, we're looking at exponential functions and graphing them. So here's your exponential function that we're going to be graphing. F of x equals 3 times 4 to the power of x. We are going to graph it, and then we're going to identify all of these parts. Okay? Remember when we were graphing the exponentials, we found like 3 points using a T-chart. So somewhere along, I'm going to do mine off to the side. Let's do a T-chart. So we have x and y. And remember, we're going to plug in x, and then whatever we get is going to be our y. Do you guys remember what the numbers that we picked were? -1, 0, and +1. And we really only need 3 to get a good sketch of the graph. So when I plug in -1 for x, that gives us 3 times 4 to the power of -1. What does 4 to the power of -1 do? And a negative exponent means you have to flip it, right? It doesn't make the number negative, it makes the number flipped. So that's going to be 3 over 4. Because the 4 changes to a 1 over 4. And then when we multiply by 3. Okay? Well, because we have 4 to the -1, so that changes it to a 1 over 4, right?
Oh.
And then 1 over 4 times 3 over 1 gives me 3 over 4. Okay? What about when I plug in 0? That's going to be 3 times 4 to the 0. What is 4 to the 0? Ooh, not 0. 1. So that's 3 times 1, which is 3. And then 3 to the first power is going to be 3 times 4 to the first. What is that going to give you? 3 times 4, which is 12. So let's graph this and see what we end up with. -1 3/4. So you're going to go left 1 space, and 3/4 is not quite up 1 full space. So you're going to go just under 1. So somewhere -1 and then somewhere underneath +1. The next point is 0, 3. So you're going to go up 3. And the other point we got was 112, which is going to be off the graph, but it's growing really, really fast. So here's what it should look like. Remember, your line gets really, 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 really close to the x-axis, but does it ever actually touch? No. And then it's growing really, really fast. So your graph should look like that. Something like that. What type of function is this, guys? Good, exponential. So let's label some of these things. X-intercept. Does my graph ever cross the x-axis? No, so there's none. What about the y-intercept? What's the y-intercept? 3, but you have to put the x in there too, so 0, 3. And that's because we multiplied by 3 on the outside. If that 3 wasn't there, what is always the y-intercept? Do you guys remember? 0, 1. But because we multiplied by 3, it changed it to a 0, 3. Asymptotes. Asymptote was the line that the graph never ever crosses. Which line does this graph never ever cross? The y-axis, which is y equals 0. Or I'm sorry, the x-axis, which is y equals 0.
Oh, I was like...
No, this is the x-axis, and it never crosses, but that's where y equals 0. The domain has to do with the x values. Remember, this graph is growing out forever and ever and ever. So do you guys remember what the domain always was? All real numbers. And you can use that symbol for all reals. Because you can plug in any x you want, and you will get an answer. That's what it means. But the range is a little bit different because we never hit some y values. What y values do we never hit? 1, here's 1, there's a point there. Here's 2, there's a point there. Here's 3, the negative ones, right? So our range, because look, I never get below y equals 0, right? Here's 0, here's 1, here's 2, the graph never goes below there. So your range is y greater than 0. Can I be equal to 0? No, because it never touches. And then, is this one increasing or decreasing? This is increasing, so we're going to say increasing over the entire domain. And we have to write that because that means that it's always increasing as x's grow. So for every single x, our graph is always increasing, okay? If it was like a parabola, we would say increasing, then decreasing, or whatever. But because this one is always increasing, we say increasing over entire domain. So we also translated graphs here. You just summarize what I have written here. You don't have to write all of the words word for word there, but summarize what I have written. Okay, so this was, we were translating graphs up and down. And so part 1 gives us the function f of x equals negative 10x, and we want to shift it 5 units to the right. Now, when we moved our graphs up and down, it behaved exactly the way we thought it would. Remember, if we moved it up, we added. If we moved it down, we subtracted. When we were moving left and right, it was the opposite of what we always thought. So if we moved to the right, we would actually subtract. And if we move to the left, we would actually add. Do you guys remember this? So the x's always behave a little weird. So let's take a look. If I am moving 5 units to the right, is that affecting the x values or the y values? The x. So remember, when we're affecting the x, we put parentheses around the x, and that's what we change. Let's call our new functions. What letter do you guys want to do? D for Dodson? Or Dana? So d of x, you can choose whatever letter you want as long as it's not s. So our new function, d of x, equals negative 10 is not affected because it's not the x. Negative 10 affects the y. So remember, if we're going right or left, we put parentheses around the x, and then we change inside those parentheses. So if I'm going 5 units to the right, will I be adding or subtracting? Subtracting how many? 5. And that's your new function. So remember, because we're shifting to the right or left, we're affecting the x value. So we subtract directly from the x. If we were affecting the y, we would subtract from the whole thing. Okay? So if we're subtracting or adding from the x value, make sure you put it in parentheses. Okay? So let's look at b then. B says g of x equals 3 to the power of x, and we're going 4 units up. Does that affect the x or the y? The y. So do we have to put parentheses around the x, or do we add or subtract from the whole thing? From the whole thing. So our d of x is going to equal the whole thing, so rewrite the whole thing, 3 to the power of x. And if we're going up, am I adding or subtracting? Adding. So all of that plus 4. Okay? So remember that was called the result and the argument. If we're affecting the x, that's the argument. So we change the x directly by putting parentheses around it. If we affect the result, the y, you add or subtract to the, just on the end to whatever you're doing. Okay? So will you guys do part C on your own? Part C says h of x equals 2x to the power of 2 after a translation of 1 unit down. Okay, so d of x equals, since we're going down, does that affect the entire result, or does that just affect the argument? We're going up and down, that's the y's, so that's the entire result. Argument is just the x, just what you plug in. The result is your y, what you spit out. So that's going to be 2x squared, and then what am I going to do? Subtract 1 from the whole thing. Okay? If I was moving right and left, I would put the x in parentheses and subtract 1 from that. Okay? Same thing here for example 4. Let's just do them really, really, really quick. I just want you to describe it in terms of the basic function. So let's just go through it. F of x equals x plus 3 squared, and here's your basic function, x squared. Am I changing the x or am I changing the whole thing in this case? Just the x, because it's in parentheses, right? So that means I'm moving it right and left. So if I'm adding 3, which direction did I go?
Right.
Remember, left and right is the opposite of what you think. So you're going left, how many spaces? Left, 3 units. That's all I want you to do. Okay. What about f of x equals b to the x plus 1? And here's your basic function, b to the x. Am I adding 1 to the x, or am I adding 1 to the whole thing?
So,
To the whole thing. So that means it's shifting up and down. And if I'm adding 1, I'm shifting where? Up, how many? 1 unit. Okay. The last one, f of x equals b to the negative x, and your basic function is b to the x. So we changed the symbol. We made it a negative. So that's a reflection. And because we took the negative of the x, not the negative of the whole thing, it's a vertical reflection. So about the vertical line, x equals 0. So it's going about a vertical line. That's a vertical reflection. Okay?